Namaste students. Now we are discussing about that is LPP. In LPP in the last session we have seen two kinds of problem, that is nothing but what we need to do when we get here feasible region as unbounded, and we have seen two problems about when feasible region with unbounded, that is minimum problem and maximum problem. In case of minimum we are continuing, we are finding out the corner points and their values we are finding out. And in case of maximum, if it is unbounded means we are stopping it there. Now we'll see today some other kinds of problem where we don't get the feasible region exactly. So now see the problem there. Maximum z is equal to 3x minus 2y subject to constraint x plus y, that is lesser than or equal to 1, and 2x plus 3y, that is more than or equal to 4. Now we'll find the values for this equation considering unequal constraint as equal. Now take the equation. X plus y is equal to 1, 2x plus 3y is equal to 4. First equation, second equation. Now find out the values for the equations. Take the first equation, that is x plus y is equal to 1. If x is equal to 0, y is equal to 1, then if y is equal to 0, x is equal to 1. Write the values x, y, 0, 1, and here 1, 0. This is from first equation. Take the second equation, that is 2x plus 3y is equal to 4. Now here, if x is equal to 0, this is 0, what will remain? 3y is equal to 4, so y is equal to 4 by 3. What happens in case of 4 by 3? We get y as 1.33. So we take 1.3 as y. Now, if y is equal to 0, if this is 0, then 2x is equal to 4. So x is equal to 4 by 2. There we get x as 2. Now here write the values x, y, 0. When it is 0, we get y as 1.3. And when we take y as 0, we get x as 2. Now plot this on the graph. Take the x-axis and y-axis. Take x and y-axis. Here y, and this side it is x. Now see the values. What values we need to plot? Here. See there. X-axis you see. Here it is 1 and here it is 2. So we can go with either 0.5, 1, that is not necessary. 1, 1, 2, 3 also we'll go with 0.5. 0.5, 1, 1.5, 2, 2.5. Now, then see there y, there 1.3 and here it is 1. There also will go in the same. 0.5, 1, then 1.5, 2, 2.5. Now write the scale there. There x-axis is equal to 1 centimeter, and what units we have taken? 0.5. Y-axis is equal to 1 centimeter, that is 0.5 units. Now see there, from first equation, there x is 0 and y is 1. and y is 1 and x is 0. This is from the first equation, that is 1 to 1. We get values from 1 to 1. What is that first equation? X plus y is equal to 1. X plus y is equal to 1. Now see the second equation. Second equation, that is x is 0, y is 1.3. 1.3 means 5 will come here, an error here 1.3, and next x is 2. X is 2 here, y is 0. So next one we get here line. This is from second equation. What is that equation? 2x plus 3y is equal to 4. Now first and second equation we plotted. Now see there the sign. The first one, x plus y, it is less than or equal to 1. This equation, it is less than or equal to 1. Less than means it comes towards the origin, towards the 0. So lines will come to this side. Now the second equation, you see the sign is over there, greater than means it moves away from the origin. It is the second equation, moves away from the origin. Now you find the feasible region. Feasible region means where the lines of both the equations should fall. Now can we say this is the feasible region? No, because there is only the lines of first equation. This side if we take only the lines of second equation, and then this is not at all, there is no line of any of the equation. So is there any feasible region? In this problem there is no feasible region. So here we cannot get any kind of solution because there is no feasible region in the graph. So here what we need to conclude? Here the given LPP has the given LPP has no solution. So no table, nothing. If we get feasible region, then only we can identify the corner points, then only we can get the value. So this particular problem ends here itself. We can end this problem here itself. Now this is about where you will get no solution. If we get no feasible region, there will not be any kind of solution. We will see one more problem under same kind. Now see, we will see one more problem. Read the problem there. Maximum z is equal to x plus y, subject to constraint x plus y less than or equal to 1, and 3x plus y that is greater than or equal to 3. Now we will take the unequal constraints as equal. Then we will get two pairs of values for each equation. Considering unequal constraint as equal. Now take the equation. X plus y is equal to 1. X plus y is equal to 1. Then 3x plus y is equal to 3. This is the first equation and this is the second equation. Now take the equation one by one. First one, x plus y is equal to 1. If substitute the values now, if x is equal to 0, y is equal to 1. If y is equal to 0, then x is equal to 1. Prepare the table, present the values on the table. X is equal to 0, y is 1, y is equal to 0, x is 1. Take the second equation, that is 3x plus y is equal to 3. If x is equal to 0, then y is equal to 3. If y is equal to 0, if y is equal to 0, what will remain here? 3x is equal to 3, x is equal to 3 by 3, so x is equal to 1 then. So we get values as when x is equal to 0, y is equal to 3. When y is equal to 3, x is 1 there. Now plot these values on the graph. Prepare the x and y axis. X and y axis. Y axis and x. 0, 0. Now see the x-axis, here it is 1 and here also 1. So we have value, maximum value in x-axis it is 1, but we'll take 1, 2, 3, at least till 3 we'll take. Now y-axis it is 3, there it is 1, so here also we'll take 1, 2 and 3. Now write the scale here. So x-axis is equal to 1 centimeter is equal to 1 meter. Y-axis is equal to 1 centimeter is equal to 1 meter. Now see the values and plot those values on the graph. Here you see x is 1, x is 0, y is 1. Here y is 0, here x is 0, y is 1, correct. Here x is 1, y is 0. So from the first equation we get 1, 2, 1. So what is the first equation? X plus y is equal to 1. Now see the second equation. X is 0, y is 3 and x is 1, again x is 1, y is 0. From here 3 to 1. We get equation like 3 to 1. 3 to 1. And see the second equation, that is 3x plus y. 3x plus y is equal to 3. Now see there, what is the first equation side? That is less than. Which is the first equation? This is the first equation. Less than means it comes towards the origin, and more than. What is the more than means? What happens? More than means it moves away from the origin. Now, can you see feasible region in this particular problem? No, we cannot see feasible region in this particular problem. That is because we don't have the region where the lines of both the equation will fall. This side if you see, here the lines are falling second equation which is moving away from the origin. And this location if you see, here also lines are falling one equation, that is the first equation. So this is the reason where there is no lines of any of the equations. So this particular problem, it doesn't have any of the feasible region. So we cannot obtain solution from this given problem. So what we need to conclude? Here given LPP has no solution. Given LPP has no solution. So we cannot obtain value for this particular problem. Now we can conclude with this kind of problem. Now lastly I will do one more problem under LPP. Then we can wind up with the topic of LPP. Now till here what kind of problems and all we have seen? We started with the maximum problem where we get unique optimal solution. Then one more minimum problem, there also only one minimum point. Then we have seen the problems of multiple optimal solution where we get two solutions for the problem. Then we have seen the unbounded problem of maximum and minimum type. And we have seen two more problems of no solution. Now one more last problem I will do, then we can wind up. We will move towards the next problem. Now we will see the last problem under LPP. See the problem there. Maximum z is equal to 3x plus 5y. X plus y, it is greater than or equal to 1500 and y is less than or equal to 600. See, till now we used to solve where we used to get x and y, both the variables in both both the equations. So here, see there y has only one variable we have, that is y. So how we need to solve this particular equation and how we need to present in the graph, we'll see that. Now firstly we have to consider this unequal equations as equal. So considering unequal constraint as equal, then take the equation there. What is that first one? X plus y is equal to 1500. It is first equation. And second one, y is equal to 600. This is second equation. Now take the first equation. That is x plus y is equal to 1500. Now, if x is equal to 0, then y is equal to 1500. Then, if y is equal to 0, x is equal to 1500. Now, present it in the table. X, y, that is x is equal to 0, y is 1500, and when y is equal to 0, x is 1500. It's not necessary, you can see from here and also, and you can plot there. This is for easy identification and drawing. It is not necessary you have to present in a table. From here also you can see. Now take the second equation. Now what is the second equation? Y is equal to 600. This we have to take as y is equal to 600 only. We don't have one more variable, that is x. Now this we have to plot on the graph. Now take the graph here. Here y and x here. Now see the values. Firstly, x you see that is 1500 is there. Y is also 1500. Here y is 600. So we need to go till 1500 and we also require that 600 also. So we'll take here how we can take. We can go with the 300, then 600, then 900, then 1200, then 1500. Here also we'll go, we can plot one more, that is 1800. Now this side also will go with the same way, that is 300, 600, 900, 1200, 1500, and last one 1800. Now write the scale here. So here scale, that is x-axis is equal to 1 centimeter. That is, what is the unit? Unit is 300 unit there. Then y-axis, that is 1 centimeter is equal to 300 units. It is 300 units. Now see the first equation, that is 1500 and 1500. There x is 0, y is 1500. Where y is 0, x is 1500. So first equation, there we need to draw. We have to take the lines or equation, that is 1500 to 1500. What is the equation? That is x plus y is equal to 1500. Now see the next one, that is y is equal to 600. What we need to do? Either, for example, we get here x. If we get y here, y is 600. From here you have to draw one straight parallel line. For in case here if it is now it is not y is equal to 600. For example, x is equal to 600 is there. So what we need to do? Here we need to draw one vertical line. Here we need to draw vertical line. If it is a y means straight one horizontal line you have to draw. Horizontal line you have to extend. Where one more line will be there, equation there. It has to cross and it should go. That you have to extend. If it is y means we have to draw horizontally. We have to extend the line. X is vertically we have to extend the line. So here it is y. Now we'll see the side. What is that second equation? Y is equal to, right here, y is equal to 600. Now, see the side. The first equation x plus y, it is less than or equal to. Less than or equal to. This is less than or equal to, so comes towards the origin. It is coming towards the origin. It is coming towards the origin. First equation. Now, second equation. What is that? Second equation is, even second equation is also less than, even this is also coming towards the origin. Second equation also coming towards the origin. This is second equation, this is first equation. So what is the feasible region? Now this region only the lines of this equation, first equation. So this cannot be the feasible region for this problem. And here also the lines of only second equation will come. So this is the feasible region for this particular problem where the lines of both the equation will fall. Where lines of both the equation will fall. So we got that feasible region. So this is the feasible region. Now for your feasible region, identify the corner. Which are the corner? This is one corner and here one more corner, that we write as B. Then one more corner C. And last one we can write it as O. This is O, corner O. So 4 corner points A, B, C and here O. Now write the values for the corner points. Equation, what is the equation? Z is 3x plus 5y, 3x plus 5y, then corner points. Which are the corner points? A, B, C and O. A, B, C and O. Now find out the values for the corner points. What is the value for A? Y is 600, we know. X is 0. So 0, 600. Then come to B. B, what is the corner points? We can take it as 900 here. X is 900. Y is anyhow y is here. This point y is 600. X will get 900. 900, 600. Then we will see the C there. C, we know X is 1500. X is 1500. Y is 0. Y is 0. X is 1500. And last one where both X and Y is 0. X is 0. Y is 0. Now substitute into the equation. Here first one 3 into 0 plus 5 into, what is the value of Y? 600. So what do we get? 5 into 600 means we get there 3000. For first one we get as 3000. Next second one, that is 3 into 900 plus 5 into y as 600. So here we get value as 3 into 900 we get as 2700 plus 5 into 600 we get as 3000. So when we total it we get, that is 3, 4, 5, 5700. Here we get 5700. Then next one, Z is equal to 3 into 1000 And how many 5700 is there? Only one 5700 is there. So what we need to conclude? The given LPP has unique optimal solution. So we have to conclude here. And write conclusion here itself. The given LPP has unique optimal solution. The solution is Z is equal to, what is the value? 5700. It is a maximum value. And where X is equal to, what is the value of X? 900. And Y is equal to 600. So this is the conclusion. With this we can wind up with the linear programming problem. And in linear programming problem, initially we have seen how to formulate the linear programming problem. We have seen the formulation of LPP. We have worked out 4 problems on the formulation of LPP. After seeing formulation of LPP, there are 2 methods to solve the LPP problem, that is simplest method and graphical method. And simplest method, according to your syllabus, we are not following the simplest method. We are finding out only through the graphical method. And under graphical method, we have seen the problem of, as I said, there is unique optimal solution where you get only one solution with maximum and minimum we have seen. And where do you get 2 solutions, also we have seen one problem. Then we have come across with the unbounded solution. What we need to do when we get minimum and when we get maximum. Maximum we cannot get the value because we get Z value as infinity. So we can get value for the minimum unbounded problem. Then we have seen 2 problems related to where we get where we are not getting feasible region. If we are not getting feasible region means we cannot obtain the values for minimum or maximum. And lastly we have seen one problem where we get only one variable. What we need to do? If it's a y means you have to draw horizontal line, and if it is x means you have to draw a vertical line depending upon the values. So with this we will wind up with the linear programming problem. And in the next session we will see about transportation problem. As I said here, 5 units we are going to study. So we completed with the first unit, linear programming. Next in the next session we will see transportation problem. So thank you.